All right, this is the last encounter that we're going to work on today. It's actually a combination of landforms, so 6.2, and then erosion, deposition, and weathering. Well, really, erosion and deposition is what we're going to pay attention to. So how it affects those landforms is 6.1. So we're mushing it all together and really just giving you a big overview right now. So let's get started. Now, the way I'm going to look at this is it's going to be divided into two screens. So first we're going to look at the erosion agents, so the agents that cause the erosion, and then we're going to look at the agents that cause the deposition. So the agents that cause erosion are highlighted in blue at this point. So water, waves, wind, glacial ice, and gravity. Okay, let's look at water first. In Florida, we're pretty familiar with that. So what we see a lot of is we can talk about each of these things. We see fast moving water or slow moving water, which is what we have in Florida because of our flat terrain, will carry particles with it and therefore erode or rub against the land for the most part. So we can have larger boulders moving, we can have larger tiny particles of sediment. However, when the energy of that water settles out, that's when our sediment falls and deposits. Okay, but right now we're going to focus on erosion. So some things that affect Earth's surface, water can cause, okay, floodplains, canyons, and lakes and rivers. We have lots of lakes and rivers here. We have lots of floodplains. Canyons, not so much, okay? But the difference between these lakes and rivers and floodplains that we have in Florida versus the canyons is these canyons have some really high elevation and most likely high relief. And if you look really closely, you can see the river on the bottom of that, and what it's doing is it's pretty much shallowing out, or not, it's pretty much carving out is probably a better word, that canyon. So that water continually erodes that canyon and keeps on making the relief higher and higher, a larger relief. Okay, floodplains is pretty much, we call it like it see it. We see lots of flooding right there, all right, and eventually that water will evaporate, but behind that, it actually erodes the land. That's why flooding's not good for us. And then lakes and rivers. This is actually a river, or excuse me, a lake in Florida. I believe it's called Oxbow Lake. But you can see how it's actually eroding the land. Obviously, there was a center. This was all land at one point, excuse me. And so you can see that it's actually been eroded. We have tons of rivers, I believe, or more rivers than what we actually named on our model, but we do have a good, like, I guess, larger rivers that stand out. So those are the ones I wanted you to identify in your landform. Let's take a look at, let's see, wind. With wind, and we talked about wind a lot today as an agent of erosion. These are just, these can be small or large sediments again, but what's going to happen is this wind is going to carry these particles, and due to them carrying them, we have the potential of running into things. So that causes abrasion. So you can see on the part of the canyon up there, or the mountain, whichever that is, maybe it looks more like a mountain, to the left-hand side of that picture, you can see where it actually, the wind, where it has particles have hit the side, there's actually abrasion taken place. There's also something called desert pavement, and it's pretty much like it sounds. It's dry, there's lots of little tiny particles, and pretty much it's just wearing away. And when our feet rub on it, we feel the bigger particles while the sediment wears away and gets smaller and smaller as we rub against it. I believe it's like cobblestone. Okay, and then the picture next to that pretty much describes how wind erodes the land. So you can see boulders creeping and you see the smaller particles suspended and moving forward. Or further, I should probably say, eventually coming to a stop. Waves. We see lots of waves in Florida with our beaches, okay, our inlets. What happens if you look at take a look, I sort of kind of wanted to give you an idea of what it really looks like in terms of pictorially, like if you had to see, like if I had to draw this and describe what's going on versus an actual visual of what we do see. So you can see where the waves come into that cliff, and the dotted lines is where the cliff used to be. So it's actually retreated backwards because that erosion, that water erosion has come in, and what happens is that cliff falls off. due to gravity, which is a weathering agent, but also you can see, and also an agent of erosion, but you can see how waves and water actually erode, okay, or cause those cliffs to fall. Salt water actually plays a part into waves if we're dealing with a salt water like the beaches, but not like a freshwater lake. But salt water actually can change the consistency of a rock. So you're looking at chemical weathering there as well as erosion. But be careful on what it's asking. Okay, so your salt water is going to change your minerals within your rocks. Glacial ice. Well, we obviously don't see a lot of this in Florida. In this case, you can see where this glacier has come down between, it's sort of kind of made a U-shaped valley. So you see your glaciers, because they're so large in size, they're so slow moving, they actually make more of a U-shaped versus a V-shaped. Your V-shaped valleys compared to your U-shaped valleys are forming because of their age. So think about that. Where would your V-shaped valley, which one would that be, older or more mature is probably the better word, or younger? Research that, look that up. That's something to look into. It's pretty cool actually. Again, like I said before in Encounter 1, glaciers are not these soft, fluffy little cloud things. They're very dangerous. They move sediment, they scrape, they do a lot of abrasion. Think of a skint knee underneath, and how whenever your knee scabs up after you fall in the cement, that's like an abrasion. That's what the glacier is pretty much doing to the ground, to give you a visual. Gravity. We see gravity actually affecting Florida a lot, because this really has to do with our sinkholes and our slides, our landslides. But this is commonly referred to as mass wasting, which you won't hear, but you'll hear sinkholes. Okay, and pretty much a sinkhole is something, and you can see in the picture, that's actually occurred for a long time. It's been brewing underneath. We just couldn't see it. Okay, so all of these particles, this rock has become more permeable due to water underneath, plant roots, all that type of weathering, and eventually you see gravity take its shape in the form of a sinkhole. Okay, so either this will be a slope, you can have things caving in on each other. This is actually a pretty easy one compared to things that I've seen. All right, so let's take a look at agents of deposition at this point now. Again, you see the same things taking place. There's water, waves, glacial ice, wind. I could have included gravity, but I would hope that you think that deposit, gravity, something falls, it deposits. Okay, that's my thought in that. So I didn't think I would need to restate it again. Let's look at water first. Okay, deposition really is just the laying of sediment. So you're going to see riverbeds. This is where your deltas form, your tributaries that lead into your deltas, which lead into your rivers, and your V-shaped valleys. Okay, your agents of deposition. Now, these V-shaped valleys, pay attention again to the V-shaped versus the U-shaped. So up at top, you see your delta. So right there at the tip of looks like the sand and then the water. On the bottom, that's actually the St. John's River right there in that picture. And that's actually a tributary that's running off the mouth of the river, St. John's. And then you can also see like a visual view of really what your riverbeds and things are looking like whenever you see your bays, your marsh. People ask me a lot about marsh, like what is that stuff when you drive over there by the big cross, or that bridge over there in St. Augustine, you see all that grass, that's marsh. Okay, so fine sand and silt, a lot of deposits, a lot of nutrient-rich soil. So think about those things. Let's take a look at waves. We see a lot of waves. Think about what they deposit. They deposit our beaches. That's where our sand comes in. Guys, it's not just water rolling in with those waves, and you know that. Majority of you have been in the beach, hopefully, in the waves. And you know that there's a lot of sand and seashells involved in that. So it's actually depositing and making those waves. Now, beaches, but depending on how tumultuous it is, depends on how much they leave behind and how much it actually erodes the dunes or the land that's already there. So beaches, sandbars, everybody been on, hopefully you've been on I haven't been on one sandbar, little chicken. So, but those are those things that you can stand on. It looks like people are in shallow, shallow water, but what's happened is it's actually deposited that sediment. And then it, right at the other end, there's a large cliff. So you have to be really careful on those actually. Sometimes they're gradual. And then there's spits. A spit is actually just like a piece of land that actually was once there. So think about it, it was once there, but it's actually developed and from that piece of land. So you can see the little sand spit over there by the beach. Okay. Wind. We talked a lot about wind and the boulders with water and the sediment. Again, the same concept. The sediments are going to move. You're going to see erosion at the front of the hill, deposition at the end. So you can even think of like your sandbars like this in a way with waves. And it's actually depositing it over time. So you see eroding, eroding, deposition, eroding, eroding, deposition. Your dunes are a good example of this. Now this obviously is a desert. Our dunes in Florida look a little different from that. We've got a lot of sea oats and all that kind of stuff out there. Okay, but actually the sand dunes are actually what's protecting us from those waves, and it's actually helping prevent our coastlines from coming forward. Now glacial ice we don't see much of. I keep saying this, but this is really sort of kind of giving you the pictorial view of what's actually being deposited by those glaciers. So underneath at the very beginning on the left-hand side of that picture, you can see the sands and the gravel that's actually deposited by the rivers ahead of the glacier, and the glacier's coming down. Now you don't need to know all those specifics of the glacier. I really don't mind about that, but you can see the specific word is called till, where you see the materials dumped as ice melts, so it continually falls off. That's those things that you see falling. Okay, so pretty much this is a wrap-up of how your landforms are affected by deposition and erosion. Hope this helps.